my name is Faiz. I am from DCC30112. Today, I and my teammates want to present about direct shear test. First and foremost, allow me to introduce myself and my team members. First is me, Ahmad Faizuddin bin Muhammad. My registration number is 01DKA20F1013, and second is Luqman Hakim bin Hasrul Nizam. His registration number is 01DKA20F2009. Third is Muhammad Haziq bin Nur Helmi. His registration number is 01DKA20F2013, and the last one is Nurul Syabiha binti Hamdan. Her registration number is 01DKA20F2019. Okay guys, I will present about introduction. So what is shear strength? Shear strength is external resistance per unit area that the soil mass can offer to resist failure and sliding along any plate inside it. Next, what is direct shear test? Direct shear test is most suitable for consolidated drain test, especially on granular soil or stiff clay. Objective for this test is to determine the soil shear strength parameter of friction angle and cohesive of granular soil. Theory for this experiment is shear soil strength can be determined by direct shear stress. In this experiment, soil sample will fail if extra plane shear stress is added to the predetermined normal stress. From the test, failure of soil depends on failure of undergoing two types of stress, which is normal compact stress caused by vertical force and shear stress caused by horizontal force. Okay, that's all from me. Next presentation will continue by Haziq Nur Helmi. Thank you.
Hi, Assalamualaikum everyone. My name is Muhammad Haziq bin Helmi and my metric number is 01DKA20F2013. And I will continue this presentation with apparatus. First, we use a direct shear box machine. And number 2, we use vela plate. Number 3, we use porous plate, and number 3, lot plate, and number 5 is hammer. That's all from me. Thank you.
Thank you so much to Mama Azik for allowing me to continue with this presentation. Hello everyone, my name is Luqman Hakim bin Hasrul Nizam. My registration number is 01DKA20F2009. So right now I'm going to continue with this presentation about the direct shear test procedure. Let's get into it. And yeah, there we go, the procedure slide. Okay, so first of all, we have to take a specimen of soil to be tested from undisturbed sample. The second step is we have to assemble the two halves of the shear box using connecting pins. The third one, place the base plate inside the box. Next step, number 4, place metal plate instead of perforated stone, as this test is for undrained condition. The fifth one, place one grid plate without perforations over the metal plate, such that the grids are perpendicular to the direction of shear. The sixth step, carefully place the soil specimen inside the box so that it rests on the grid plate. Step number 7, over the top of the soil sample, place another grid plate without perforations such that the grids are perpendicular to the direction of shear. Slightly press this grid plate evenly so that the grids are buried into the sample. The 8th step, place another metal plate over this grid plate. And step number 9, place the loading pad on the top of the metal plate. Step number 10, place the adjusting pins in the box. Step number 11, place the shear box inside the shear container. Okay, based on what I've mentioned just now, this is the shear container, and inside of it, here we have the shear box that we have to put it inside. For step number 12, we have to assemble the probing ring, and the next one, slight movement of the pointer in the dial gauge is an indication that contact is established. Okay, for your information, this dial gauge is actually from the proving ring that we have assembled from the previous step. The 14th step, place the dial gauge for measurement of horizontal displacement. And then, step number 15, fix the dial gauge on the loading yoke to measure the vertical displacement. For step number 16, we have to set all dial gauges that we have put or assembled to 0 reading. This one is from the proving ring. This one is from the previous step that I have mentioned just now, the dial gauge for horizontal and the vertical displacement. Both of these from horizontal and vertical displacement. All of these dial gauges, we have to set all of them to 0 reading. In step 17, we have to place a steel ball on the spherical groove provided on the loading pad. Step number 18, seat the loading yoke on this ball that I mentioned just now. In step 19, we have to raise the upper half of the shear box to 1 mm by operating the adjustment screws. For your information, the adjustment screws that we have to operate is this 4. 1, 2, 3, and 4. Okay, for step 20, remove the pins connecting to upper and lower half of the shear box. So here, as you guys can see right here, you can see like a person pulling out something from the shear box, right? So that's what we call the pin. In step 21, apply the required normal load on the hanger of the loading lever. For the present case, it is 0.5 kilograms per centimeter square. The next step, step 22, set the clutch and the gear for applying shear displacement of 1.25 mm per minute to the sample. In step 23, we have to switch on the machine and stopwatch simultaneously. In step 24, record the readings on the 2 displacement dial gauges and the proving ring dial gauge at regular interval of time. For the 25th step, continue applying the shear force till the specimen fails, which is indicated by a kickback of the pointer in the proving ring dial gauge. So here's a picture of the result of this experiment. So basically, this is how it's supposed to look like after we finish this direct shear test experiment. So the description, shear soil specimen which was under the test that I've explained throughout this procedure presentation. And the last but not least, the final step, 26th step, conduct at least 3 tests on separate specimen having the same density and moisture content but applying different normal loops. Now that I finished with my presentation part, which was about the procedure of direct shear test, so right now I'm going to pass this presentation to Nur Shabiha to continue with the data. Thank you so much to all of you for willing to lending your ears listening to my presentation part, especially to our lecturer, Madam Nur Asya. Thank you so much. Have a good day.
Assalamualaikum and hi everyone. My name is Nur Shabiha binti Hamdan. My metric number is 01DKA20F2017. Now, I will continue this presentation. Data. For test 1, the normal stress is 0.5 and shear stress is 0.37. For test 2, the normal stress is 1 and shear stress is 0.55. And lastly, test 3, the normal stress is 1.5 and shear stress is 0.77. To calculate shear stress, the formula is shear force divided by area of specimen. From this data, we will plot a graph. Draw a graph by plotting normal stress as x-axis and shear stress as y-axis, and then connect the lines on y-axis and measure the intercept. This gives cohesive. Draw a line by plotting normal stress as x-axis and shear stress as y-axis, and then connect the lines on y-axis and measure the intercept. This gives cohesive value which we get 0.14 and measure the angle which we get 23 degrees. In conclusion, the symmetrical direct shear test is an effective method for the measurement of the plane strain and direct shear angles of friction and sand and the angle of dilation at the density and stress level tested. The measured plane strain shearing resistor corresponds closely with the minimum value with respect to strength. A simple modification for the standard laboratory direct shear apparatus and suggestions for the analysis of standard test data are recommended. Common errors can come from handling the sample incorrectly or too much during preparation, causing disturbance in the sample. Next, not allowing the salt to consolidate fully. The last common errors is using a larger shearing strength. Doing any of the mentioned probable causes of error can affect the shear strength of the sample. Disturbing the sample can affect the structure of the sample, which reduces its strength, and not allowing full consolidation and using a larger shear strength increases pore water pressure, which reduces the shear strength of the sample. That's all from us. Thank you.